All of the climate forcings and systems we've talked about so far today affect Earth's climate individually, but they can also interact with each other to create further changes in Earth's climate. And these are known as climate feedbacks. Climate feedbacks are when changes in one system or forcing can cause changes in another system or forcing. And when we talk about climate feedbacks, there are two main types, a positive feedback and a negative feedback. So before we jump into thinking about specific climate feedbacks that are positive and negative, let's take a step back and just think about what a feedback is and what a positive and negative feedback would look like. So a positive feedback is when a change in A causes a change in B, which in turn causes a change in A in the same direction as that initial change. And an example of this is shown on the left. An example of a positive feedback could be the relationship between the number of infected people and the amount of a virus. For example, if there's an increase in the number of infected people, there will be more of this virus that can spread. And since there's more of the virus available to spread, we end up with more infected people. So in this case, the initial change in infected people resulted in a change in the virus in the same direction, and that resulted in a change in infected people in that same direction as well. So if we look at how this would affect the overall change over time, as a positive feedback occurs, the number of infected people would increase over time. In contrast, we can look at an example of a negative feedback, which is when a change in A causes a change in B, which in turn causes a change in A in the opposite direction as the initial change. So an example that we can look at for a negative feedback is the relationship between the population of a prey and predator. In this case, elk and wolves. So for example, if we have an increase in the number of elk, there'll be an increase in the number of wolves. However, as the number of wolves increase, the number of elk will then decrease. And over time, what we end up with is that the change in the population of wolves will vary on short time scales, but overall, there's a relatively constant population of wolves. So to summarize, the main takeaway and the main difference between the positive and negative feedbacks is that in a positive feedback, there's an exponential growth that occurs, whereas in a negative feedback, there might be some short-term fluctuations, but there's an overall balance that's maintained. Now we can take a look at examples of climate feedbacks and climate feedback loops, which is when multiple processes are interacting. So if we think about a positive climate feedback, we might start out with an initial warming, and this warming creates some sort of change in the climate system that speeds up the warming process. And this would create a positive feedback loop that causes increased warming. Now, if we look at an example of a negative feedback, this initial warming would create some change in the climate system that actually slows down the warming and may even create cooling. So this negative feedback would balance out the warming and create a more steady change or lack of change. So now we can take a look at some specific examples of positive and negative climate feedbacks. So one example of a positive climate feedback is the ice albedo feedback. So in this scenario, increased warming will result in ice melt. As ice melts, the albedo of the surface will decrease. And the albedo is the amount of light that is reflected from a surface. So bright surfaces such as ice or snow can reflect more sunlight, whereas dark surfaces such as soil or rock will reflect less sunlight. So this melting of ice results in decrease in albedo, so more of that incoming solar radiation gets absorbed. And when we have increased radiation being absorbed, this will amplify that initial warming. So we end up with a positive feedback. And this positive feedback creates increased warming. Now, an example of a negative feedback related to climate is the cloud feedback. So again, if we have this initial change of increased warming, this can result in increased evaporation. Then this increased evaporation will result in lower atmospheric clouds, and these atmospheric clouds will reduce the amount of incoming solar radiation that reaches Earth's surface. And because of this reduction in solar radiation, we end up with opposite signal of that initial increased warming. So we actually end up with a cooling effect. So overall, this negative feedback would cause cooling in response to this initial increased warming. And in some cases, these feedbacks can play an important role on Earth's climate on different timescales. For example, the positive ice albedo feedback that we just discussed plays an important role in sea ice melt that occurs each summer. But this feedback also plays an important role on timescales that are much longer. For example, as anthropogenic warming results in a decreased sea ice cover, this can lead to enhanced warming from an increased area of open ocean, which has a lower albedo than the ice. And the influence of the ice albedo feedback on regions with annual ice is something that we'll start to explore in this tutorial. Regions on Earth where temperatures are cold enough to sustain annual sea ice are in the high latitudes. But this region is changing significantly with global warming, as we just discussed with how the ice albedo feedback is changing. So in this tutorial, we'll explore sea surface temperature maps, and we'll use masking tools in order to analyze parts of the map where sea surface temperature is below 0 degrees Celsius. In other words, we'll use these tools to understand changes that are occurring in parts of Earth where this ice albedo feedback is having the most significant impact on the